Okay, this is the video for section 10.2, talking about regression. Okay, and the following are our learning objectives that we'll be able to construct scatter plot of paired sample data. Okay, and use technology to find the equation of the regression line, or what we call the line of best fit. And then we can test a hypothesis and decide also whether the model that you get is a good model and it was a bad model. If it's a bad model, how do you use that equation to predict? Okay. So the regression line to predict what future values. So the regression line is given that it's a collection of paired sample data. Okay. Or sometimes we call it the line of best fit or the least square line. Is a straight line that best fits what the scatter plot of your data. Okay. And it is of the form y equal to, say, y hat. This is it's of the form, the equation of a line is what, mx plus what, plus b. So in this case, my y, this is the predicted y value. Okay. Predicted y values. That is your y hat. Okay. That is this guy here. And then this is your y-intercept. So b naught is your y-intercept. Okay. And then your b1 is what, the slope, which in this case, if you compare to that, that is your m. All right. So the regression equation expresses a relationship between x and y. X is called, that names for is what, this is the y is the dependent variable, x is what, the independent variable, or is also called the explanatory what variable, or predictor variable, or independent variable. So it has three names. The y hat is so the response variable or the dependent variable. So response, independent, predictor, okay, and then dependent or explanatory variable for the x. Okay. Now, to be able to find the regression equation, there are certain requirements. You want to know that the paired, the x and y, they are what? Random sample of what? The quantitative what data. Okay. And then two, the visual examination of the scatter plot shows that there is the points approximate a straight line pattern. Okay, outliers can have a strong effect on the regression equation. So remove any outliers if they are known to be occurring by error. Then consider the effects of any outliers that are not errors. Okay, so well, now finding the equation of a line, of the regression line, we need to know what the y-intercept and then the what b hat, and these are how they are calculated. But the StatCrunch will give us this. But just to explain that, this is your correlation coefficient. This is the sample standard deviation of what the y values, and that is a sample, okay, standard deviation of the x. That is for this one. And then if you find the slope of the mean of the y and the mean of the x, and then if you evaluate this, you get a y-intercept. Okay, but StatCrunch will give us this, but in case you want to know how to calculate that. So we're going to use technology to find a regression line. Okay, StatCrunch will give us that. And we want to consider a data, okay, corresponding to the Nobel prizes that we Nobel narrate what rates. Okay, the table data is on the next slide. Okay, so how do we find using technology to get this Nobel Prize? Okay, so I'm going to use the go to start my MATLAB and then show you how we got this. This is the data set. It comes with the textbook, and that is a scatter plot for that. And this is our what, regression line. Okay, this is the regression line. This is the regression line, or the regression equation. So the chocolate and then Nobel. So that means the amount of chocolate consumption gives you that. Now notice that this is 23. So here n is what, 23. It's not like the only five that we considered last time in the previous section. So let's just see how this is done. Okay, I'm going to stop sharing and I'll open my data set. Okay, so let me share this with you. So I go to the data, there's my start lab. Okay. My start lab, and then go to the main. I just want the data set that comes with this. So I go to StatCrunch, I open it from there. Okay, data sets from your textbook. Then if I scroll down a little bit, I go to Norates. Okay, Nobel, Norates, and then chocolate data set. So let's open that in the StatCrunch. Let's make sure that you're seeing that. Okay. All right, so the chocolate is my X, the Nobel is my what? Your Y. So go to stats, regression, simple linear. X is your chocolate, Y is what? Your Nobel, and then a compute. Okay, when I compute this, this is where I got my regression equation. Okay, this is the correlation coefficient, which is 0.8001. The square of that is 64, as we talked about in the previous section. That's my p-value, that's my test statistic. Okay, and if we go to the next page, this is my scatter plot with the equation of a line. When I put the cursor on it, it highlights the equation of a line. So y, there's a y hat equal to negative 3.367 plus 2.493. Okay, so the y-intercept is negative 3.367. The slope is 2.493. Okay. All right, so let's go back to the PowerPoint. Okay. So now this is where, that's why I got this with the scatter plot and then what? The equation, the regression line. Okay. Now, when you have outliers, we say that they affect, or outliers or influential what points. Okay. So in a scatter plot, an outlier is a point lying far away from what? The other points. Okay. And influential points, the per sample data may include one or more influential points, which are points that strongly, okay, underline, strongly affect what? The graph of the regression line. It strongly affects it. Okay, so we're going to demonstrate this. Okay, the data set we considered, okay, there's a 23 pairs. Okay, now we want to include this data, x equals 50 and y equal to equal to 0. Okay, this is the original when we haven't added. So that is my scatter plot with the regression line. Now, if we include this is the graph, the scatter plot we're gonna get with the line. Now look at it. This is the influential point. Look at how it has changed, affected the what? The regression line. Okay, look at the slope, and the slope of this is almost close to what? Very zero. Okay, now let me demonstrate that using the scatter plot we have. So I'm going to show my, okay. So what will happen is that I'm going to add x is 50, the chocolate, and then this is 0. And I'm going to construct the scatter plot for the same thing. So let's close this. Okay, and go to the process again. Stats, okay, regression, simple linear. And then I select my x, and that's my y is Nobel, and then compute. Okay, now look at it. Look at the regression equation. Look at the correlation coefficient now, which is 0.0553. But without that influential point, it was 0.801. Okay, now look at the scatter plot. Can you imagine that? Look at the point that we are talking about, the influential point. So see how it's affected what? The regression. Okay, so very important to know that. Very good. Okay, so now let's go back to our PowerPoint. Okay, so when you have influential point, they really affect the regression line. Okay, so as I stated, is the example influential point has this, the correlation coefficient is 80.1% when without the influential point, but with the influential point, it is what? 5.3%. Okay, now that indicates that there could be a bad model. Whenever you have a regression line, doesn't mean it's good. We can test that if it's a bad model, of course, there's no correlation. That's another way to say that. Okay, but if it's a bad model, how do we use that equation to predict future values? Okay, so making predictions. So regression equations are often useful for predicting the value of what? One variable, given some specific what? Value. Okay, a bad model, if the regression equation does not appear to be useful for making predictions, don't use the regression equation at all. All that you need to use that, when that's the case, the best predictor is what? The sample mean of your what? The predictor of your response variable. So that is this is your what? You use what? Y, mean of the Y. Okay, so that is the summary statistics of that. Okay, a good model, if it's a good model, then of course, substitute the X value into the model and find the response variable. Sorry, response value. Or that's your Y hat. That's what it is. Okay. Now, test of hypothesis. Now, everything in this textbook is always, most of it is what two-tail. Okay, but doesn't mean it cannot be one tail. Okay, it could be, but it depends on, you could say that, or test the claim, it depends on the claim that there is a positive word correlation, so that if it's positive, that is greater than zero, that's a right tail. If it says that there's a negative correlation, then it's what's going to be negative, less than zero, so it's going to be one tail. Now in this class, correlation, the rho, okay, there's rho, always the null hypothesis is that the rho equals what? Zero. That is no correlation. And there is correlation if it is not equal to zero. Okay. It depends on the claim. All right. Now, this is the test statistic. Okay. The test statistic with the 2 degrees of freedom. Again, StatCrunch will give it to us. The test statistic, we're going to pick it from using, like you are testing for the slope, which is the B. If you use B equal to 0 for your HO, and your H1, your B is not equal to 0. Now, the reason is that the correlation, the R has the same what? The same sign as what? As your slope of the regression line, this one, the BO plus what? B1X, okay? Has the same. So if the correlation, if B is positive, this correlation will be what? Positive. If it's negative, it's going to be negative. And so in terms of the regression lines, it will have the same kind of what effect. And so the StatCrunch output gives us we use the test statistic for the slope as well as the p-value, okay, for the same what? Correlation when we are testing rho equal to 0 versus what? Rho is not equal to what? 0 for correlation and no correlation. Okay, so here's what we say, that if you are claiming that a positive linear correlation, then it's going to be a right tail. If you are claiming that it is what? It's a negative linear correlation, then that's going to be what? A left tail. Okay, so that's a possibility. So now, making predictions. Use the regression equation to predict only if the linear correlation coefficient indicates that there's a linear what? Correlation. So if you test that there's a linear correlation, that means that it's a good model. So use the equation to make future what? Predictions. Okay. Now the scope, all right, of the line for predictions only if the data do not go much beyond the scope of the variable available sample data. So if your X values ranges from say 2 to 10, and they ask you to predict, okay, predict Y for x equal to say 13. Now this is beyond the limit of what there were x values. So it cannot use that. Okay, you cannot use that. It has to be within that, within the range of the sample data that you have. So you got to be careful how to use the predicted value. Okay, the figure on the next slide summarizes a strategy for predicting values of what y when given some value of x. Okay, so the strategy is a regression line, a good model. Okay, that means the regression line graph, a scatter plot shows what it faced what the points. Well, it's a straight line. There's a R indicates a linear correlation, and then the predictor not beyond the scope. Now, if the answer is yes, use the regression model that you have or the regression line. If no, then use what y bar for any x value. For any x value, regardless of the x value, use what y bar. Okay. Then we can also use the residuals to determine whether it's a good model or a bad model. Okay. That is, we have a good model or a bad model. Okay. If it's a good model, then the residual should show certain things. The residual is what the observed y minus predictor value. So this is your residual. Y minus what? Y minus y hat. Okay. Then if you plot x against the residual, which is y minus y hat, okay, and get a graph that it has to, if there's a pattern, if they show any pattern at all, then it's a bad model. If it doesn't show any pattern, then it's a good model. Okay. So we're going to plot residual plots is what the x versus what as I indicated. Okay. And then if you plot this, you analyze the residual for the following. Okay. That the residual plot should not have any obvious pattern. Then it is a good model. Okay. Now, if it has any pattern at all, it should not become much wider or thinner when viewed from what left to right. So that shows some pattern. So basically, if it has any pattern, right? If it shows some kind of pattern, then there's what this is a bad model. Sorry, that's a bad one. Okay, so you can test formally, okay, using the format test for, okay, where do you say the row equals 0 versus what the row not equal to 0, depending on it's a true tail. Otherwise, if it is what a left tail or right tail, we just want to know positive or negative respectively. Okay, now that is one way to know that it's a bad model. All right. Second is using this the residual to know whether it's a bad model or not. Okay. Or you can use the p-value to decide when you test this. If it's a bad model, you know. Okay. So if it's a bad model, this is what we expect. Now look at the second and third word graphs of the residual. Now these two are bad models because the residual shows some pattern. Okay, for this first one, that one is it is thinner and gets wider. Okay, then this is bad. Now for the first one, doesn't have it doesn't show any pattern at all. So that is a good model. Basically, it's like you have almost the same number of points lying above the line and then below the line. Okay, this is 0. All right. Okay. So now let's consider examples 2 and 4 in the from the homework. Okay. So I'm going to stop sharing this. All right. So this is the 10.2 homework question number 2. We are doing questions 2 and then 4. Okay. So they said a 50 match pairs of magnitude and depth measurements randomly selected from 10,594 earthquakes recorded in 1 year from a location in Southern California. Find the best predicted depth depth of an earthquake with a magnitude of 1.6. So we want to make a prediction for that using the model. So we have to see whether it's a good model or a bad model. All right. So use a significance level of 5%. Okay, these are data points. So we're going to open this in the StatCrunch. There are 50 of them. So open this in the StatCrunch. Okay, so let's making sure that you are seeing that good. Okay, so StatCrunch, we go to statistics and we have regression simple linear. Okay, the magnitude is your X and then the depth is your Y. And then you just go compute. All right. Now, if you look at this, this is my scatter plot. This is my scatter plot. So you see that there's no pattern at all. If there's a line of best fit, there's no pattern at all. There's no straight line pattern. So from this, I can say that it's not a there's no linear correlation between them. So it's a bad model. Okay. However, if I want to use this output, this is my regression equation. Okay, and they want us to run it to, I believe, the 2 decimal places. So we're going to write this down and enter that into the homework. Okay, so we have 9.061 plus 1.56, and then that is your X is your magnitude. Now the p-value, all right, p-value is what's 0.06106, and my test statistic is 1.9226. Okay, now what am I reading this from? Look at my correlation coefficient is that my R is 0.268, okay, which is very small. This is my p-value, which is 6%. So if 5% is greater, so reject the hypothesis that there is no correlation. Okay, so if you want to do that, this is what we have there. Okay, so now let's go back to the homework. All right, they want us to find the what? It says to 1 decimal place, so that is 9.1, and then this is also 1 decimal place, so to 1.6. Okay, all right. So now, given the earthquake is this a good model or bad model? Now, to do that, that is where we have to what? Let me share my screen. Okay. I hope you are seeing that. Okay. Okay. I need to test. Okay. From the output, I know that I'm going to do a test, right? The format test here. My null hypothesis is that your rho is equal to 0 versus the alternative H1 is that the rho is not equal to 0. Okay, my p-value, okay, is equal to, well, alpha. Okay, alpha is what, 0.05. P-value is 0.0661. Okay, so you notice that in this case, p-value is what? Is greater. Okay, it is greater than 0.05. So reject the what? Rejected now. Do not reject HO. So meaning that there is no what? There is no, linear correlation. Okay, hence this is what? This is a bad model. Hence a bad what? Model. So if it's a bad model, then to predict any X, okay, any X, we use what? X bar. Okay, so this is a bad model. So to predict for X equal to, the question says X equal to 1.6, there's going to be the value of what? Y bar. Okay, so I go to the StatCrunch. Okay, show that to you. Okay, It's a bad model, so I need to find the y, the summary statistics of that. So summary statistics of the columns, and I just need this, and I just need a mean, and I compute that. So that the mean is what? 11.22. Okay. So when I go back to my homework, okay, it said to one decimal places, one decimal place, so that's 11.2. Okay, that is why we have this. All right. Okay, so that is it. Now let's go to question number 4, example 4. All right, here it says that we are given this data set and we want to find the scatter plot, want to find the regression line, okay, and look at the characteristics of it. Okay, so again, let's open this in the StatCrunch. Let's make sure that you are seeing that. Good. All right, so let's do the regression. Stats, go to regression, linear, simple linear. X is your X, your Y is your Y. Okay, and then everything stays the same. If you are testing, the rho is what? 0, which is the same as the slope equals 0 in this case. Okay, so let's go there, and this is our scatter plot. Okay, go to the front. The first page is that, so we can write down, we need a regression line, the test statistics, and all those, if they are, that's what is given. Okay, so we have our p-value is 0.0117 to 3 decimal places, which is this one here. Okay, that is the one. That's the p-value. My R is 0.698. Okay, my y hat, the equation is 3.222 or 2172218 plus 0.491x. Okay, if they need a test statistic is 2.926. Okay, so let's go to the problem and enter these ones. Okay, so let's share 10.2. Our scatter plot is actually, and it is a B. Yeah, it is a B. Okay. So then regression equation is round the constant to 2 decimal places and then the coefficient of the x to 3 decimal places. And so this is to 2 decimal places. So that will be 3.22, I believe. I hope I wrote it well. And this is 0.4491. I hope that is, yeah. I wrote it carefully. All right. So what do you think? Identify the characteristics of this. Okay. Now, if you go back to this graph, okay, this point right here seems to be an influential point. Okay, that point. If you go to the scatter plot, let me make it to my StatCrunch. Okay, if you look at this graph, this point here is an influential point, which is what? The x is 11, y is what? 12.9, which is this value, this one. Okay, so if I remove this and I construct this scatter plot to be different. So in this case, all that we need to do, that's an influential point. Okay, so the answer is that there's an influential point that strongly affects what the graph of the regression line. Okay, now to verify that, just to show you, okay, let's go back, and I'm going to delete this points from there. Okay, I'm going to delete that, and then I want to copy and make sure there's no missing variable or values. I don't think I need that one. Okay, so let's construct the data regression construct the graph again. So go to stats, regressions, and simple linear, X, and then Y. Okay, there will be a vast difference between them. Now, look at the regression equation. Look at the correlation coefficient. Okay, from like a 69.8% to what 96%. Now look at the graph. You see how removing that influential point, look at the graph. So it really affects that. That is why we got the answer. Okay, we chose that there's an influential point based on the characteristics. All right, so let's go back to, that is actually the end of the of this section. Okay, and I hope this is helpful. Thank you. Mhm.